So, you've just wrapped up the Hello World tutorials for Compose Multiplatform. You get the basic building blocks, you know how to put a button on the screen. But what now? That leap from a simple component to a real, fully architected shippable app can feel like you're trying to find your way through a super dense fog. Well, think of this explainer as your map. This question from a developer over on Reddit just gets right to the heart of it. And it's a feeling I bet a lot of us have had, right? It's like you've learned all the grammar rules of a new language, but you have absolutely no idea how to actually write a story. That's the exact gap we're going to bridge today. And this is it, that what now moment. It's this huge chasm between knowing the syntax, how to build individual little pieces, and understanding the big picture. We're talking architecture, navigation, managing data, the whole shebang. So the real question is, how do we build a bridge over that gap? This follow-up comment really nails the problem, especially for folks coming from the web world. How do components talk to each other? How is state managed? It's a fundamentally different paradigm, and this points to something absolutely crucial. The first step isn't about learning a new library. It's about adopting a whole new way of thinking.
Okay, so let's dive right into that mindset shift. Because before we even touch on architecture or any specific libraries, we have to get our heads around the declarative way of building UIs. This is the bedrock. Everything else is going to be built right on top of this.
This lays out the core difference perfectly. A lot of us are used to the imperative style, right? Where we write code that manually tells the UI how to change, step by step. But Compose just flips that whole idea on its head. With a declarative style, you just describe what the UI should look like for any given state, and the framework itself figures out how to make that happen. Think of it this way. You stop being a micromanager of every little UI element. Instead, you become an architect of UI states. Your job is to define all the possibilities. Is it loading? Did it succeed? Was there an error? And then you just describe the UI for each of those states. The framework does all the heavy lifting of rendering the right view at the right time. And there it is, the aha moment, right from the original developer's follow-up comment. For anyone who's ever touched a framework like React, this is where the light bulb goes on. You realize your UI is just a function of your state. Simple as that. Once you really internalize that idea, all the other pieces start to fall into place. All right, so with that declarative mindset locked in, now we can talk about structure. How do we organize this state-driven approach so it doesn't become a mess? Well, that's where architecture comes in. It's the blueprint for your app, making sure your code stays organized, testable, and ready to grow. A really popular pattern in the Compose world is MVVM, which stands for Model View View Model. The key idea here is just separation of concerns. Your UI, the view, is kind of dumb, and that's a good thing. It just knows how to display state. Your data and logic, the model, are totally separate. And the view model is the bridge, holding and preparing that state for the UI. This separation is so important because it makes your logic super easy to test and way easier to debug when things go wrong. Let's just trace what happens when a user does something. It all starts at the UI layer with your Compose code. A user taps a button, which sends an action to the view model. The view model might call a use case to do some business logic, which then talks to a service layer to grab some data from an API. That data then flows all the way back up, updates the state in the view model, and boom, that automatically triggers the UI to recompose and show the new information. In this layered approach, which you'll see in patterns like MVVM or the very similar MVI, is what gives your app a solid backbone. By giving each layer a very specific job, your code just becomes way easier to understand, to test in isolation, and ultimately to scale up. A blueprint is great, but you can't build a house without tools, right? So let's assemble our toolkit. These are the essential multi-platform libraries that are going to bring each layer of our architecture to life. So, for your services layer, Ktor is a fantastic networking client from JetBrains themselves. To manage and provide all these different pieces, a popular choice is Coin for dependency injection. For moving between screens, Compose has its own really powerful navigation library. And for turning that messy API data into nice, clean Kotlin objects, you're going to want kotlinx serialization. And make no mistake, these tools are mature and seriously powerful. Just take Ktor, for example. JetBrains reported a performance boost of 30 to 90% in its latest major release. That sends a pretty clear signal, doesn't it? This isn't just some hobbyist ecosystem anymore. This is a professional-grade toolkit that's evolving fast. Okay, so we've adopted the mindset, we've designed the architecture, we've assembled our tools, and we have a working application. But now for the final and most crucial step, shipping it.
How do we take our shared Kotlin code and turn it into a native app that anyone, anywhere, can install and run? The magic here is the Compose Multiplatform Gradle plugin. This is a tool provided by JetBrains that basically automates the whole complex process of packaging your app into the native formats that users on macOS, Windows, and Linux actually expect to see. Now, under the hood, the Gradle plugin is using a standard JDK tool called JPackage. What this does is it bundles your app's code, along with all the necessary Java runtime parts, into a single, self-contained, installable file. And the best part? This means your users don't need to have Java installed on their system at all. It just works. And the result is exactly what you'd hope for. From a single codebase, you're generating the native installers everyone's used to. Standard .dmg and .pkg files for macOS, .exec and .msi for Windows, and of course .deb and .rpm packages for Linux. This is the multi-platform promise, fully delivered. And getting this into your workflow is surprisingly simple. It really just boils down to running a few Gradle tasks. You can run the app locally to test things out, you can create the final distributable, or you can package it into a specific format like a .dmg or an .xe. It's a really streamlined process, all handled by the build tools you're probably already using. So all of this, it brings us to a final big picture question. When you have one single framework for your declarative UI, one language for all your logic, and one plugin to ship native installers to every major desktop OS, has that old dream of write once, run anywhere finally become the practical default choice for modern developers?